All right, so section 3.4 is all about solving using the quadratic formula. Most of you have probably never been as happy as you are right now at hearing the words quadratic formula, because you get to use the quadratic formula to solve things, and most people like to use the quadratic formula to solve things anyway. And I've been forcing you to use different methods like solving using roots, solving using completing the square, and so on and so forth. Completing the square, I said earlier, is one of the most useless ways to solve something unless you plan on dealing with calculus in the future, okay? But the quadratic formula is one of the most efficient ways because it can solve every single one of the problems. Some of you only learned quadratic formula in Algebra 1 because you knew that you could just do the same thing over and over and over and over again, all right? So remember, the quadratic formula works for questions like this, where it's ax squared plus bx plus c equals 0. And then the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now in this class, what we're going to be talking about more is kind of the applications about this versus the actual solving of it. You guys solved this stuff. You've been solving stuff that looks like this for the last several weeks. You know how to simplify a radical. You know how to plug numbers into an equation and solve them. You know how to do this. So that being said, I'm going to be giving you some applications with this stuff so that you can kind of think about what that thing means. All right. So let's go through one example of a quadratic formula before we start with our applications, so that way we know exactly what's going on. Okay. So that one example is going to look something along the lines of this, where we have like 2x squared plus 4 equals negative 7x. I'm going to give you guys a second to plug this in and make sure that you still understand what's going on. And then we're going to come back and talk about it in a second. So now what we're going to do is move everything over to one side of the equation so that we can solve it very easily. But remember, they have to be in the form of equals 0. So I'm going to move that negative 7x over. So it's going to be 2x squared plus 7x plus 4 equals 0. Now, if you think about this, we could use the Brooklyn method, right? We could try the Brooklyn method. 2 times 4 would be 8. So I'm trying to find two numbers that could multiply together to give me positive 8 and add together to give me 7. The only numbers that multiply together to give 8 are 2 and 4 and 1 and 8. None of those can add together to give me 7. So that being said, I can't use Brooklyn method. My first check with trying to solve these is always seeing if I can factor like normal first. It's so much faster to factor like normal for me, and I don't really want to do this if I don't have to. So I know that my A term, my A term is this one, my B term is this one, and my C term is this one. I'm just going to plug all of those into the formula. Once you plug them into the formula, you're all done, basically. So B is 7, so opposite of 7. Or opposite of B. The opposite of 7, plus or minus the square root of B squared is 7 squared minus 4 times A, which is 2, times C, which is 4, all over 2 times A, which is 2. This is what it should look like. Now, one important thing, you have to keep these exact the same way that you did before. They still have to be exact. They cannot change. So they still have to be exact. Don't do anything different with them. They still have to remain exact. Okay? So now I'm just going to rewrite this as negative 7 plus or minus the square root of 49 minus 36, I think, or for 32. All over 4. So then you can simplify it a little bit more than that. So when you simplify a little bit more than that, you get negative 7 plus or minus the square root of 49 minus 32 is 17, all over 4. And now I would see if I can break down the square root of 17 at all over here. And it doesn't look like I can, because I can't break it into two numbers that work nicely. So I could test 4, that doesn't work. I could test 9, that doesn't work. And then obviously 16 won't work. So my final answer is going to look like this. Everybody good on quadratic formula? Now, something really, really important. This can still happen with imaginary solutions, okay? This can still happen with imaginary solutions. You could have a negative number in here, but that doesn't change anything. We've been solving those for a long, long time. So it doesn't matter if there's a negative on the inside of the radical. You can still solve that, okay? So now what we're going to do is we're going to get into applications. And this is applications of something called the discriminant. So our whole quadratic formula looks like this. This thing right here is called the discriminant. So that thing right there is called the discriminant. Now we can figure out some things about the discriminant, or about the question from the discriminant. All right. So we can figure out exactly how many solutions there are going to be just from this thing, just from this right here. Because if you think about this, if you take the square root of a positive number, you're going to get two solutions, right? Like if we say the square root of 4, the square root of 4 is both positive 2 and negative 2, right? If you think of the square root of 0, the square root of 0 is just plus or minus 0, which is just 0. So that means there's only going to be one solution, right? And then if we think of having the square root of a negative number, which is something like the square root of negative 4, we know that we would have to pull an I out of there, and it would make it be plus or minus 2i. So this would be two imaginary solutions. And if you think about what's happening up here, I'm taking a number and adding it to a number. A number plus a number is still going to be a real number, right? If I take a number and I add 0 to it, a number plus 0 is just going to give me whatever the number was to begin with. A number minus 0 is going to give me that same number. If I have imaginary solutions, I'm still going to have two solutions. I'm going to have a plus and a minus. If we go back and look at the exact same thing that just happened here, I still have two solutions here. The square root of 17 is a number. Whatever that number is, so the square root of 17 is 4.1. So this is saying negative 7 plus 4.1 divided by 4, or negative 7 minus 4.1 divided by 4. There's still two answers here. Even though that number is not nice, there's still two answers that we can deal with. That's what the discriminant can tell us. Okay? So I'm going to write down in kind of like the real words what things look like. But we're talking about the number being positive, the number being 0, or the number being negative. That's what we're really dealing with. Okay? So if b squared minus 4ac is positive, bigger than 0. If b squared minus 4ac is bigger than 0, we are going to have two real solutions. Which means that if you have a graph, the graph, no matter what, is going to cross the x-axis 2 times. So no matter what, that graph is going to cross the x-axis 2 times. If you have a b squared minus 4ac and that thing is bigger than 0, it is going to cross that axis twice. Okay? The next one is when we have b squared minus 4ac equal to 0. If I have b squared minus 4ac is equal to 0, I'm going to have one real solution, which means that I'm going to have my graph is going to touch the x-axis one time, which means that the vertex is going to be on the x-axis. It doesn't matter where it's located, but it's going to look like that. Excuse me. And then finally, the last one is when we have b squared minus 4ac is less than 0. This would mean that I have two imaginary solutions because it would be a negative inside the radical. And if it has two imaginary solutions, that means that my graph would never ever cross the x-axis. So that's what it would look like. All right. So this basically tells you the number underneath the radical. If the number underneath the radical is positive, two real solutions. If the number underneath the radical is 0, one real solution. If the number underneath the radical is less than 0, two imaginary solutions. Okay? So let's run through an example of what that could possibly look like on a test question. You guys do have a couple questions on big ideas that are due tonight that we're going to have to work through. So like if I said something like this, find the number and types of solutions. 2. And then I give you a question, and that question is something like, it's not super easy. Uh, 5x squared equals 8x minus 13. If I give you one like this, the first thing that you would do is you realize that this type of question is asking you to just do b squared minus 4ac, and then tell me what happens with it. You could solve this if you wanted to, but that's going to be a waste of time because it's not asking you for the answer. It's just asking you find the number and types of solutions. One real, two imaginary. That's what it's asking you to do. So I'm going to rewrite this as 5x squared minus 8x plus 13 equals 0, just so I don't mess up my a's and b's and c's. This is my a, this is b, this is c. So I know that I'm going to plug b in here. So negative 8 squared minus 4 times a times c. So then I'm just going to solve this thing and say this is 64. So and I should put parentheses here, hang on, so that we don't get confused later on. So this is going to end up being 64 minus, what is that, 260? 4 times 5 is 20 times 13 is 260. So that's going to give me negative 196. So this is saying that b squared minus 4ac is less than 0 because 196 is less than 0. So that means this is going to be two imaginary solutions. Any questions on this that you can think of right now? Okay. So the last thing that I want to talk about today, because I want to give you a little bit of time to work, is just the same kind of concept as this, except that little concept is going to make you kind of go the opposite direction. Okay. So it would be something along the lines of, it would be find a possible or find a pair of possible. Find a pair of possible integer values for a and c such that, math people like the word such that, ax squared plus 4x plus c equals 0 has two real solutions. So it's saying that I want this thing to have two real solutions, but I don't have values for a or c, so I have to find those values. But what I know right now, with two real solutions, that means that b squared minus 4ac has to be positive, right? So b squared minus 4ac has to be positive. So if b squared minus 4ac has to be positive, I'm going to plug in whatever I know from up here, and the only thing that I know up here is that this is b. So I'm going to plug in b squared. So 4 squared minus 4ac has to be bigger than 0 because I want it to have two real solutions. Okay? So I'm going to say, now I'm going to solve. That's what I'm going to really do. So I'm going to get 16 squared minus 4ac is greater than 0. I'm sorry, not 16 squared, 16 period. So 16, I'm going to subtract 16 from both sides. So I'm going to get 16, or no, hang on. I'm all frazzled now. So I'm going to get negative 4ac is greater than negative 16. I can't even write. And now what I need to do is just solve this part. So now I'm going to divide by negative 4. Now someone please tell me what happens when I divide by a negative with an inequality.
It flips the inequality sign.
I have to flip the sign, right? So it's going to be AC is less than 4. So I have to find two numbers that multiply together to give me something that is less than 4. Can anyone think of two numbers that will multiply together to give me something less than 4? Any numbers at all?
1 and 2.
1 and 2. If A equals 1 and C equals 2, because then that means A times C is going to be 2. 2 is less than 4. This is a pair of possible values. It's not the only pair of possible values. You could use 1,000 and 0. You could say A equals 1,000 and C equals 0, and that would still work out the same way. But all you're doing is applying this formula and then solving that formula to find the way to get that possible pair of values. Okay? So this is what's really happening. Okay? So on your homework check on big ideas, you're going to have a few things that you're going to have to do. Number one, you are going to have to be able to do what you see in front of you right now with the discriminant. You are going to have to be able to solve using the quadratic formula. And finally, for number 3, you have to know when it's efficient to be able to solve certain equations in certain ways. You have to know if it's efficient to solve using the quadratic formula or if it's efficient to solve using factoring. It's almost never efficient to use completing the square. So the 3 efficient ways would be solve using roots, solve using factoring, solve using quadratic formula. And I would say they go in that order. I would say solving using roots is the fastest because you can check it easily. Factoring should be quick because you can check it easily. If neither of those 2 options work, then it goes to completing this, or not completing the square, quadratic formula. That's what I would suggest to you. Okay? So I'm going to stop recording now and then we can go through any questions that you guys have.